Right. Hi, everybody. My name's Mark. Yeah, as I said, or in the introduction, I'm going to talk about some testing strategies and tools for games testing. I spent a lot of time in games testing, but most recently I've been at Unity for a while. Uh, Came up as an SDET, doing a lot of tools and automation, things like that. But been in leadership, kind of leading a lot of teams, doing a lot of that kind of thing, as well as doing a lot of test strategy, test planning, things of that nature. So I wanted to kind of share my experience and more like from a enterprise sort of testing situation towards more of like an indie development, kind of help people level up their quality mindset, testing strategy type thing. So, moving beyond playtesting is the theme of the talk. So, with that, um, give you more insight to my background. So I graduated from RIT from uh, from near Rochester, from Oswego originally. Um, Out of school, I interned at Microsoft. I worked on the CNET games. Came back as full-time at Microsoft. I worked on Alan Wake, which is one of my favorite games I worked on in my career. It's a lot of fun. Helped out on Crackdown 2. Those games I built, some automated tools. I did a lot of like data gathering and making sure sounds triggered in the right ways, scripts triggered in the right ways. A lot of data, learned a lot of SQL there. That was kind of my SQL battleground testing. And then moved on as a lead tester, eventually working 343 on pretty much everything. I worked around those games, worked on everything but those games, and that was more where I got outside of games and worked on, a lot of web tech, mobile apps, even Xbox apps. That's the big thing with Xbox One was apps. So that was interesting. Learned a lot of different types of tech, different types of automated tools, and things like Selenium and Protractor and all those like things that are pretty popular now. Using those on an Xbox was very interesting to learn. Yeah, so it's helped me think about testing as at scale, as a team. How do we leverage the different skills in the team and address large scale projects like that. So after that, I moved to Unity. They wanted me to come lead their XR QA team. It was kind of this nascent team that just started. XR was like brand new in 2016. That's when I joined. Uh, it was pretty awesome. It was, I'd been a Unity hobbyist developer. I won't say indie dev. I didn't really ship anything, but I definitely used it quite often. And it was a natural fit. I knew a lot about the product. I was really excited to work on it. Getting a little burnt out at Microsoft, honestly, but and VR was like this brand new thing. It was really cool to kind of go attack a new problem and figure out how to test it. And I'll get into some stuff I learned uh, through that kind of were interesting problems I solved there. Um, and then, yeah, been there for 10 years. I moved through various platform teams, testing, desktop platforms, the editor, and then moved more towards graphics and ultimately leading the graphics QA team. So a lot of tonight comes from experience, and why testing games and games tech is very hard, and it's there are a lot of tools and things you can do to help build some strategy up front to make shipping your game down the line a lot easier. So I think I don't know if everybody's heard this. This is something been drilled into my head. The last 20% of the game takes 80% of the time. It's a lot of like bashing bugs and things like that. Play testing and iteration. As you're building the game, gets you most of the way there fast, and then you hit this wall where you're trying to put everything together, build out content, smooth out like an actual game experience, and then you start hitting all these rough edges and edge cases that you didn't realize were there. And that just takes a lot of time and iteration time to fix things, retest it, fix things, retest it. So one of the goals tonight is how to build some of that process up front to kind of smooth out that last part. So at least that iteration part is a lot quicker. You can understand if you broke something right away, if something changed in an unexpected way, it can tell you right away, and give you visibility much more quickly rather than make a change, play test it, and something's wrong, and then you have to make a change and redo everything over again. So. Um, so yeah, that's the next section. Why games are hard to test. So you probably all know this, but I like to kind of give a review of like why this is hard. Uh, Non-determinism, physics, timing, input, just general randomness in game logic can cause a lot of different outcomes from the same inputs, seemingly. So as you're playtesting things, you might just run into something random that you'll never be able to reproduce again, but you're gonna try 20 times to figure it out. You might only hit it once, or it might only happen on one person's machine, and that person is the only person that could actually try to fix the issue because they're the only one that can run into it for some reason. Um, in graphics in particular, a lot of graphics low-level API depend on floating point math, which depending on what hardware you're running on, what drivers, what graphics APIs, or even API versions can have different results for things like, anti-aliasing or any other type of pixel differentiation or any other thing that can kind of bleed into the rest of the game and cause different things on different hardware if you're shipping on different mobile devices or even just different PC hardware. You can run into those types of things. That's more things that I run into, but it's definitely part of this non-determinism problem with games tech. If you are shipping on multiple platforms, which I deal with at Unity, it's that test matrix expands fast, especially across, mobile, console, and PC. They all have different hardware, different input, different performance constraints, and how to, ship a consistent experience across all of those things. That test matrix kind of just explodes out of that, especially if you're dealing with different, input methods and how to design around that and make sure that your menus and all of your game logic deal with all of that. Different graphics APIs for, different rendering, different render pipelines, different shaders, different things like that. There's a lot of things that you need to cover. This is probably more of a problem at Unity, but we deal with large game publishers that deal with this, and I could see, someone using Unity that we promise, build one chip anywhere. It's still a testing problem at some point where you need to validate that your game works on all these different platforms and devices and hardware. So. Fuzzy correctness. So, something that feels fine or functions like the way the code is, the way you coded it, but once you actually start using it and maybe start adding content or start building some more complicated things on top of it, you realize there's like a design problem or something like that. Something that we dealt with at Unity was what we call the shader variant explosion with URP. The shader team didn't really change anything was wrong, but they had all these built-in shaders, the URP lit shader, URP unlit shader, all these different built-in shaders with URP. Nothing was broken, but teams kept adding new keywords over time, and every time they did it, the shader variant count just kept multiplying basically until like I think building the shader samples took like eight hours to build, which was ridiculous. So it kind of wasn't a problem until it became this huge problem, and kind of by the time it surfaced, it completely derailed our releases. It was a big fire drill. We're still dealing with this problem today. Honestly, we band-aided over it a lot, but we're finally doing some actual like design work around how to actually deal with this and how to actually do stripping properly and a lot of that. Now that we're getting rid of some legacy tech that we still support. It makes it a lot easier, but yeah, it was a huge problem, and something we didn't really realize until it was something that kind of snuck up on us. And if we, had some tooling in place at some point and we're measuring this, we probably would have caught it a lot more quickly. So again, more to the point of building in tooling up front to measure things that could go wrong, even if it's something that, or using tools to measure over time if things are changing. So, what's a practical test strategy for a small team, even an individual, how they could build in a test strategy for a small game, but it would ultimately lead to a much smoother experience to ship the game, ship a demo, keep builds consistent, not break anything. So, um, this is the test pyramid. I don't know if anybody else, coming from our IT, I think I had like 2 classes on QA and then ended up making this my career. So it's stuff that I've learned over time. I don't know if that's changed from anybody else going through similar programs, but this is stuff that I've learned, and kind of this, how do we build up tests over time in this pyramid shape. Cut off a little bit, but you'll be able to see it when I share the slides. But so at the bottom, there's unit tests. So how do you build deterministic game logic, and how do you prove it's deterministic and build testing around it to validate, all your internal API game object contracts, or however you're building your game, don't get broken from other changes. So this is how do you not break yourself from changes within different game modules, or even different just files, or code files themselves. Integration tests is different game systems that move together or work together. So this is how different systems in the game are coupled together. And this is more about more complicated tests. Unit tests are very self-contained. Integration tests are things that depend on each other, that are totally tightly coupled, that you want to make sure you're not breaking anything that something depends on. You can use like dependency injection or mocking here, but or you could actually, if you build the testability into your product, you can actually, spin up objects and have these integration tests built out themselves. Graphics tests, this is something that we use in graphics, but it is available in Unity, and there's also things outside of Unity and other game engines, or other tools you could use, but they're just simple image comparisons. So if you do change a shader, if you do change, make a change to a shader graph, or built-in shader, or whatever you're doing, even if you're building custom render pipeline or something like that, you can do these image comparison tests where you have like a template image that something is rendering correctly, and if you change something, you can do a comparison to see that nothing, at a pixel level with some forgiveness, has changed too drastically. So like shadows didn't break, or culling didn't break, or sorting at the Z level didn't break, or there's not Z fighting, or however it works. It could be something as simple as like changing a prefab, or changing how a game object is instantiated, or something like that. It could be you could do animated, you could do over time, or at certain frames, taking an image capture and doing comparisons. They're pretty flexible. They are somewhat fragile. You kind of have to design what these graphics tests are good for and what you're actually measuring. You can over-index on them, and it becomes a maintenance burden in itself. Ask me how I know that, because we have that problem. Performance tests, these can be as simple as just like measuring frame rate or things like that. You can do things like, building a fly-through of your level and doing benchmarking and capturing how many frames you're able to render over a certain amount of time, or average frame rate over 1,000 frames, or other measurements over a certain amount of frames. Those are different ways that we've measured performance. consistently. That's super valuable. As you're adding content, as you're making more complicated game logic, you could start, maxing out the CPU, you could start maxing out the GPU and start getting bottlenecked. And it's good to catch that early before you get into a really hard problem where you have to start moving things around or making some hard choices on, what you're doing with your game. Interaction tests, these are like, a step below kind of manual play testing, but these are what we call sample gyms in game testing in games. And it's just like a self-contained level with like all of your interactable objects or everything a player can use in your game in one location. So it's easy to find all the things and use all the things. If you change some game logic, you can run up and use a gun or like I don't know, a sword or whatever, and make sure it does the same damage and has all the same sound effects and all the other things, and that you haven't broken anything game logic wise or interaction wise with the game environment. And then at the top, manual playtesting, and that's still important. You still want to make sure your game's playable. You can complete the game, you can complete levels. I'll talk about why that's important, obviously, but it shouldn't, as I said before, beyond play testing. These are all the other things you can do to kind of build up to that in an automated fashion or semi-automated fashion before you're, just depending on doing manual play testing. So prioritization, this is something that we do in QA all the time. We can't test everything, so we prioritize. So develop, automated tests to cover difficult or time-consuming tests by hand. This is in general how we do automation. Tools that make it easy to set up different game states, manually reproduce issues, run specific tests. And then, yes, run the golden path scenario every sprint or milestone, make sure it remains playable. This is just general, like every, how we are developing our game and building that quality into it. So yeah, certification. I know not everybody deals with this. I have maybe PTSD from this, so I want to call it out from working at Xbox, but certification is a thing if you're working on a platform that requires it. Consoles mainly. I know iOS and Android have certification. They're usually like an automated job that has some certification tooling or pretty lightweight. iOS might be a little bit more complicated. It's been a while, but we used to spend a lot of time making sure we could pass certification at first time, especially even at Microsoft. Like our first time was free. If you failed, you had to pay the certification team money to do additional certification passes. And I have a note here just because I work at Unity. I know these, I want to call these things out, but in 6.3, the platform team released this platform toolkit package, which handles a lot of the platform specific, certification, platform API, cross-platform features, like at a Unity API level to make it in line with certification requirements. So it handles a lot of that stuff for you. So if you are interested or have the ability to ship on a console, highly recommend using that. Regression test suites, they're huge. Games are huge, interconnected. I mentioned that they're very complicated. They can have large halo effects. Having a comprehensive regression suite with automated tests is essential to guard against any sort of breakages. And building those at the smallest level first, so you can have IDE tests that are running as you're writing code, commit hooks. So at pre-commit hooks, so before you check in, it runs some tests to make sure you're not checking anything bad in. PR checks if you're using GitHub or whatever CI or whatever source control you're using, but you can have stuff on check-in or in your checks as your PR is being reviewed. CI, time-driven builds, kind of building up from the smallest bit to the longest, to do more complicated tests at a nightly or a weekly level. if you get to that point. And this really starts mattering, when you have your first playable build that you're giving out to people or a demo. You want to be able to make sure that your changes are not breaking anything horrible, and you're maintaining that playable demo or your playable build. So you're able to ship fixes with some confidence that you're not breaking anything horrible. So very important. So I have a question. I was gonna put a bug slide here because I think about bugs all the time at my day job, and I was kind of interested in general, like how you all track bugs. If you just do it in your head, you just kind of keep track of things. If you just write it in a Word doc or a notes file or a spreadsheet or whatever. I'm kind of interested in it, so please, we can wait till after and have a discussion on this, or you can kind of write in the text chat. So, we use Jira. I don't super like it, but it's powerful and has a lot of things you can do with it. But there's different uses for all of this, and kind of use what you like. I do think not having it just live in your head is probably useful, and writing things down is probably the first step, obviously. But as you're working on things, making sure you're writing high quality bugs, with repro steps. You might forget how you got to a point. If you have a way to like save state of a bug or something like that, so you can jump back to it, that's even better. We had tools like that could do something like that. So in my previous games industry experience. So the next section, it is focused on Unity. I did call out, I know there's not everybody at work uses Unity, gasp, but it is focused on Unity. I did try to call out other non-Unity tools. So if you're using Unreal or Godot or other engine agnostic options for tools that even work with Unity. But try to do my best here. But it is focused on Unity. Just everybody. So the Unity test framework, this is built in. It's a feature of Unity. Everybody I talk to that I know uses Unity, this is probably one of the first questions I ask if they use the Unity test framework, and I don't think anybody that I've talked to that uses it, even professional developers that are using it pretty much. And it's super powerful. There's edit mode and play mode tests. I'll get into what those mean, but edit mode's like pure C# logic. It's outside of play mode, but it's basically, think of it as a unit test. Play mode test can run in mono behaviors. They can do tests like over frames, so they can test more game logic-y type stuff. Super powerful. There's extensions built onto that can do performance and graphics tests. So I have links to docs down there. I mentioned graphics tests and performance tests here, so they can capture a lot more information for you there, and you can do captures over time to see how things are changing. And they live in the test runner window. I'll show a view of that just so you can see it in the next couple slides. And at the end, bottom, there's other things. Godot has its own thing. Unreal has its own thing. Unity is actually built on top of NUnit, so you could just use NUnit if you wanted to. PyTest. There's other things that you could do the same thing in, but there's just this built-in framework in Unity, which is pretty great, I think. So this is what the code looks like. Very naive examples, but I wanted something that fit on a slide easily, that's easily understandable. Edit mode. So you'll see the C# attribute that's just test, and this can run in the outside of play mode in the editor. You can just run it, and it will kind of track like basic game logic type stuff that doesn't depend on a mono behavior, doesn't depend on multiple frames happening, things like that. Play mode, much more flexible. It's called Unity Test. It's built on top of Unit, so it's kind of got some extra stuff in it. But yeah, you get access to everything that you have access to in play mode. It uses this yield return syntax to an IEnumerator to do things either over time or over frames, or there's a bunch of stuff there. But you know, there's documentation for all this. But I used, you know, just yield. It waits a second. So it makes a jump, waits a second, and then asserts that the player actually moved up in the Y position, so jump actually still works. And the other one adds a sword, make sure that, you know, we actually added a shield, didn't add a shield, and didn't throw a inventory full exception. I think I don't remember this code, but yeah, that's what the other test is doing. If you're interested. The test runner window. So this is these are actually graphics tests, just because I was working on some things, but I wanted to show you this. But you can see the edit mode, play mode tabs. There's a player tab, so that's actually running the play mode tests in a built player. It can be in any player that you have installed. So it could be, you know, your local, you could be running on the player for the dev machine. Or, you know, I'm on Mac OS, so it would run on the Mac OS player, Windows player. It could run on an Android phone. It could run on, you know, whatever player you have that you're currently building for. You can pick what tests you want to run. So there's one selected, rerun failed, export results, all those types of things. I didn't show all the things, but they all look exactly the same pretty much. You can categorize things. There's a lot of stuff you can do here, but this is just a basic example of what this looks like. You can get to this by going up to Window General. I think I probably should put this in here, but Window General Test Runner, and this gives you access to all the tests you ran and actually be able to run them. Okay. Again, there's on the Unreal front-end automation tab. Godot ships with its own editor panel. IDEs also have other inline test results things. Visual Studio has its own thing too, that you can run tests. I'm not sure. You could probably figure out how to run. You can run these through command line as well, through the command line parameters. I believe you might have to build some editor build scripts to actually run them, but it is possible to do this as like a CI type thing. So yeah, CI integration. So there is, if you want to use something Unity built, there's Unity build automation. It's formerly called Cloud Build. I just found that out doing research for this. We changed the name of it, of course. GitHub Actions, any other, you know, CI/CD environment, Jenkins, TeamCity, GitLab CI. They're all able to run headless Unity tests fine. Yeah, even one nightly smoke test job with some tests that you've authored is a big upgrade for any team. It just keeps building that confidence that all the changes you've made can build overnight. It'll either tell you something broke, or you know, or that everything's good. And especially if you have multiple people making changes overnight and getting kind of that even integration test level type stuff running overnight is really helpful. Debugging tools. So this is the rendering debugger example here. There's also like the frame debugger and the render graph viewer, but I just showed an example of the rendering debugger. So this actually shows, you know, frame rate. You can run this while your game's running. It'll give you a bunch of different stats. You can actually add your own markers in here. So if you want to know like what happens when I, you know, launch these particle effects, or how many particle effects are actually getting launched, and how is that affecting the frame rate, and you can map that over different. You can map that over time. There's graph views of this as well. So it's you know, the profiler, it's extensible. You can kind of build your own things into it, which is really helpful. The frame debugger, this is really interesting, especially if you're building like script, your own render pipeline, or if you're customizing like URP or something like that. It can actually give you a view of everything, all the render passes that are building the view of the scene that you're in right now. So I built a GIF to kind of explain this because it helps to look through all this and how it's actually doing. So it helps with other things too. So shaders that you're creating and part on any sort of particle effects or any sort of if you see like some weird sorting things, you can kind of just see how those things are getting built. It can give you some insights into how meshes are getting batched, and maybe some performance issues as well are really helpful. There's also Pix, which covers DirectX. RenderDocs is cross-engine. It also works with the Unity as well. There's other ones. NVIDIA has Insight, Xcode GPU, Chat Capture for Apple. These all work with Unity as well too, but we have one built in as well. They all do slightly different things, but yeah. Anyways. So finally, yeah, what working with XR and AR taught me about testing, there's really some unique things that, coming into, and this is kind of going back to 2016. Some of these might be, if you've worked with XR, these might not be brilliant insights, but these are things that I learned about. Especially with like still working with like mobile devices, they still kind of apply, but like different hardware, different input methods, different performance budgets. Depending on the hardware, you have to think about this. Thermals are definitely a thing that you have to think about. I think that's on the next slide though. I kind of got ahead of myself. But play space was something that when I first started, there was like seated, standing, and room scale experiences, and we had to plan out like just how to test all this stuff. We had to plan out the office itself around this was different sensors, and how to actually not have multiple people testing VR and have their sensors like kind of clobber each other and have some weird things happen. So we had to make sure all that testing coverage had to be explicitly scoped out and planned for. The device spectrum ran from like super high end at the time PC rigs that were had tethered stuff. So the original Quest was tethered to like plugged into your PC, and you ran from there. And then we had Google Cardboard, which was literally a phone you put into a cardboard box and strapped to your face. So Unity had to work similarly on all of those. Not everything worked on each of those, but you had to figure out what features fit in which tier. Sometimes that was like hey, find out if this works on a phone or not, and how does it work, and then you tell the developer what worked and what didn't, because there was a little bit of experimentation there, because we really didn't know at times, which was a pretty interesting way to test things. Which sometimes that's how it works. There's just experimentation, and just kind of exploratory testing, which even in games, there's things that comes to that has a place in games, is exploratory testing and just trying to break things. We had people in games testing that were just really good at finding weird things you could do that would totally break your game and breaks the save system, or get out of the environment, or break some script that was supposed to happen that would totally break progression, or something like that. Thermals is something we're still dealing with mobile devices and the new XR devices. I remember when we were first working on, I think it was the Magic Leap devices, our QA had to actually we could work on it for like an hour, and then we had to take it off and put it in like a freezer basically to cool it down, so we could actually keep testing it, or else we'd have to let it sit there and wait I don't know, 30 or 45 minutes to actually wait for it to cool down so we could keep testing it, and it just wasn't efficient, and we didn't have enough devices to switch around. So that was an interesting problem. We had to think of a novel solution to solve. Um, yeah, so there's having smoke tests to kind of hitting making sure your performance tests uh, get up to the thermal, like a regular thermal rate to hit what normal users would hit over a time, and then making sure it doesn't degrade over, a small amount of time. Most of our performance tests are just testing like, does this work over the first 1,000 frames? And sometimes there's like, a couple seconds of warm up time for shader caching or shader building or something like that. But with this, we really had to do like some soak testing to find how long would it take to kind of melt down, and that was an interesting problem as well. And then yeah, just there's a lot of working with partners and within Unity, just making sure we're handling our engine level stuff appropriately across all of these devices with the obligations we have to our partners. So uh, kind of there's like NDA requirements, and that made even things hard to talk about with people inside of Unity. So getting additional testing for other features that your team didn't necessarily own. So we had to do a lot of feature testing of Unity that on these devices. So it just added a lot of complications to testing. And additionally, I didn't have it here, but automated testing on XR like wasn't even thought of when we started building this. So that was a lot of novel solutions on how we actually did that. So, and then comfort, yeah, discomfort was a holy thing. We had to make sure that frame rate performance was a big deal there. And then design was just as important. So we had to kind of figure out what worked and what didn't. Locomotion is a big thing. Like, how do you do motion correctly and moving around without making people sick? So that was important. So finally, I have some takeaways here, some things you can try. I would try to add one automated test. I gave the example of the save system because that is something I've seen get corrupted or go wrong over time. So it's good to have something automated there that's, saving something and loading it and making sure things rehydrate properly. Turning on the profiler once a week and just seeing what happens, seeing if you can see anything interesting happen in your game, even, render doc or superluminals, also like a CPU side profiler as well. Write a 10-item smoke test checklist. So like, what are the top 10 things we want to test every day when we get a new build or get the latest changes from the team to make sure we didn't break anything and maybe start automating that over time. And then I have a couple Unity things. Project Auditors, something came out last year, which is pretty cool. It's a package that'll look at your project and kind of give you an output of some things that might be wrong with it and some things that you could do to improve performance or whatever. There's a lot of output that can happen. And bonus, I wanted to call this out because we just announced it last week, and I thought it's really interesting. And I tried to avoid AI in all of this because there's sensitivity around that. But the Unity CLI just came out last week. There's also the MCP, which also works, but CLI just got announced. You can use that with the project auditor, and if you are afraid or don't want to bother with upgrading your project, there's a workflow with using Unity CLI with a project auditor to upgrade, find issues, have your AI agent, fix it, go through project auditor and kind of do the upgrade process for you, in a separate branch, like on the side that you're not even monitoring or maybe babysitting a little bit, and try to go to the next Unity version for you. Because I always I'm trying to push people to the next Unity version because I've seen people still on, Unity 2021 or something like that. So that's it. Questions?
Great, thank you, Mark. I don't think we had any questions in the chat, so we're going to go straight to the general Q&A. Just a reminder for folks to mute yourself when you're not speaking, or switch to push to talk, or else I'll have to use my mighty mod powers on you, and I'll also send you a strongly worded DM. So with that said, let's move over there for the live Q&A.